Hey, hi everyone. So today we are going to look at some image to 3D models which help you convert a 3D image, sorry, a 2D image to a 3D model. So I was recently playing with this quite a bit to help make a 3D model of my latest car. My wife loves it very much, and I wanted to gift it to her. A small 3D printed model of the car for her, right? So I was looking at some image to 3D models. There are quite a lot of them, but the recent ones are Trellis and Huanyuan. So let me quickly show you what Trellis looks like. So Microsoft has made this sorry, Trellis 3D. Yeah, so Microsoft released this model as open source, not open source, but you can find the weights and you can run this locally to like generate a 3D model out of images locally. So yeah, so this is the image to 3D model. This repo has quite a lot of information. I think the main part here is they bundle a Grad.io app which you can run, and you can run this locally. So I have a NVIDIA RTX 3090 GPU, which is good enough to run most of these models locally. So I went ahead and I actually installed this. So if anyone wants to install this, they have mentioned a Windows. So there is a thread which actually installs this in Windows. It actually takes some time. So it might not be very straightforward as it is on Linux, but since my work PC is Windows, I tend to use this one. I tend to use Windows for my weekend projects, right? So yeah, so if you want this thread, if you on this GitHub page, you will find a link to this thread, which actually goes over installing this on Windows. I think this is the key part. This comment is the what helped me install it. Uh, Try this. If you face any issues, you can reach out to me on my channel or on my email, which I've linked in the channel. I'll try to help you out on running this on Windows. Just make sure you have a nice GPU which can handle the load and which has enough memory to run this model. So once I did this, I was able to run this. Yeah, so I was able to run this locally. So just to start, I'll just show you. I'll just start a local instance of this. Let me start Anaconda. Yeah. So yeah, so for people who are not familiar with Anaconda, it helps you to bundle all these dependencies in a single sort of command. So your dependencies don't clash. And if you have used Python in the past, you know that becomes a hell to manage. So I'll just activate my Conda, what do you call it, environment. Conda activate Trellis. Yeah, so now the environment is active. Let me go to go to Trellis. Let me start the Grad.io app. So it's not as straightforward. You'll need to install it. It might take some time, but once it is installed, it's pretty simple. You just need to do Python, sorry, Python, and then you need to do app.py. That is the Grad.io app. So once you do this, it will start the app locally, and then you can just use the UI to do this. So what if you don't have a GPU which will help you do this, right? So let me give you a solution which can help people out. So if you see, they have a Hugging Face live demo here. So just click on this, and this is a Hugging Face hosted version of this app, and you can actually add images here and generate 3D assets. It will take a bit more time, but if you don't have a GPU, this is the best way to like generate a 3D model, right? So yeah, so once you do this, it will show you it, you are queued and everything. See what's happening to our app. Okay, so it's starting up. It loads quite a few bit of dependencies. uh, yeah, Triton is not required. Yeah, so if you see, now it's running on local. Let's try the localhost URL. Yeah, So you should see an app now. So what we are trying to do is we will drop some images here, and now the model will try to infer the 3D model based on those images. So one good thing about Trellis team is like it's very hard to create a 3D model out of a single image, but if you have multiple images from multiple angles, right, it becomes easier. So if you are familiar with this line of work, you must be familiar with photogrammetry, which actually does what I just said exactly. But this is a computational part. There is no neural nets involved. What we do is, like, when you run a photogrammetry software, it will estimate the camera position. Like, I think this image is a good example of what is photogrammetry. Okay, can't find that image. Yeah, but what it does is it will estimate the camera positions, and then it will try to create a 3D model based on how the light flows, right? So if you know this model looks like this from this point and this from this point, and then you basically do a computation and put all those points in a 3D space and then try to create a 3D mesh out of it. But photogrammetry has, like, I have experimented in the past. I think 2 years back, I think Alice Vision has a tool which you can use directly, but it was not good. Like the like you need to have picture perfect images and everything so that you can create a good model. I tried it with my bike sometime back, but it doesn't work. So let's do one thing, right? So the Trellis team, what they did was, if you go to their GitHub page, right? Sorry, GitHub page. They enabled this via, like, they enabled a multi-image synthesis mode, which helps you create a 3D model based on multiple images. This is, in my experience, infinitely better than just going with one image and trying to do that. You can still do that. If you see Rad.io, you can have a single image and multiple images option, but yeah, it's not very accurate. So if you see, they have added this via this issue tracker. If you see, they yeah, so apparently it was straightforward enough. I can go through this, but this is a bit too detailed to explain in a single video, so I'll just go with multiple images and show you. So before we do that, right, we need multiple images of the model which we want to create. So for me it was Franks. So let me just go to, yeah, I just searched this 360 view, right? So what I plan to do is I plan to click images from all 4 directions and then try to create a 3D model out of it. So let's try that. Let me open snipping tool, which will help me do that. Yeah. So once I do this, this is the front view. File, save as. Let me create a new folder. Front view, I'll save this image. Then I'll do a side view. So I'll save this again. So let me do this thing. Sorry. Yeah. So this is documents, Franks 1, 2, 3, and 4, and you open it. Yeah, it gets. So if you see, it has removed all the background from all the images by using RMBG. These are detailed enough images to create a 3D model. Let's see what the generation is. I won't change any of the parameters. There are definitely parameters you can tweak. I think one is sampling step, but sampling step, sometimes if you increase it, it will add more detail, but the model becomes more creative. It takes more liberties and generates things which might not be there. Yeah. So let's try this with default params and see how it works out. So if you see now, it's processing. This is running locally, so you can see it here. So sampling steps are 12. Yeah. So if you see, it's rendering it now. Okay. Yeah. So this is how the car looks, right? Yeah. So this is the generated 3D asset of how the car should look. I can just do a full screen, and you see it is close enough, at least close enough for a 3D print. You can always add more details, remove more. like this hole, right? This hole shouldn't have existed. uh, you'll have to do some touch-ups in the 3D printing software to make sure these holes are closed. Let's yeah, let's try the extract GLB option. So extract GLB will convert this image, like this model. This is basically a Gaussian splat. It will convert this into exportable file format, which is GLB for us, and then we'll try to see what we can do in the GLB format. So if you see, again, there are some parameters here, simplify and texture size, which you can tweak. So yeah, so this is the GLB file. We are not very concerned with how the colors and other things look. These are always going to be low detailed, but we are not concerned with how these look, because in any case 3D printer doesn't know. Yeah, 3D printer doesn't know the colors and everything, right? You can always set different paint colors and everything. Like if you're doing a multicolor print, you can always set this in slicer. So let's download this. Okay, so I've downloaded this. Let's open Blender. Let's open this file in Blender and see what we can do. I generally use Blender only to export it to a STL file. I know it's not the best, but yeah, it's the fastest way I know of converting a GLB file to a STL file. I'll just delete these. I'll import. So I go to import. You can see a GLTF1 here. I go to downloads. Sorry, not these downloads. Yeah. So this is the one. Yeah. So if you see, this is the car model. Not bad. Let me try to scale this up. Or let me just do one thing. Let me export this. So I go to edit mode. Yeah, so I've selected everything. I'll export this as a STL file. You can actually add more details to it. Let me try to do that. Yeah, so here you can see you can increase the scale. So if I were to do it, say 10x for all x, y, z. Yeah, so this is how the scaled up model looks. I think this should be good. Yeah, let's try to export this and see. Export. I do an okay. Wait, instead of OBJ, which is experimental, let me try STL. So I'll save this in my folder as flonks.stl. So yeah, that should work. Let me. So this should actually export this model. Before we go ahead with this, I also wanted to compare one more image to 3D model, which has gained quite a bit of support since it launched sometime, I think in the last 2 months, which is Hunyuan 3D. So yeah, I'll just show you the GitHub. So this model has, like, people have reported very nice people have reported very nice sort of outputs from this model. So, and if you see, they are quite active in releasing multiple versions. They have released turbo models as well. So if you have GPUs which are not as beefy as, say, a 3090, 4090 or 5090, you can use these turbo models, which work nicely with like low VRAM GPUs, and they also have released a multi-view shape model, which is Huanyuan 3D-2 MV, right? So I have not worked with this. One more good thing is they directly have a Blender add-on for interacting with Hunyuan 3D 2.0. I'll experiment this some other time, but just to for the sake of our comparison, right? What I will do is I'll try to install this one and see how it goes. Uh, yeah. So if you see, yeah, there is a Windows installation tool, which is yeah. So I think for installing this on Windows, let's try doing what they have asked. So oh, I think I've already installed this. Not installed, but oh wait, I think I have this, but I don't have the latest code. So let me try. Yeah. This should take some time. What's happening is this the latest multi-view changes were added pretty recently. So what I'm trying to do is I'm trying to get the latest version of this repo in the sort of in the Windows portable version, and I want to see if it works. I have doubts because last time I checked there were some changes which were in the author's original fork which were not present in the remote branch. So I think it might cause some issues, but what I feel is these are optimizations which are not strictly needed since I have a 24 GB GPU. So let me try this. Let me try to replace this folder with code downloaded from here. Perfect. Let me do a git clone. I just hope this works. So what I'm assuming is since the 3 run bat command, right, it just runs the grad.io app.py file. If we just replace it with the latest one, it should work, albeit without some optimizations which are present in the original fork. So let's try this. Okay, so after studying it a bit, after looking at the scripts and everything, this is the model which this is the part of the bat file which downloads the models. So see, text to 3D is being downloaded separately. Now the issue is to enable multi-view. I was checking the grad.io app code, the latest one, and everything depends on this MV mode variable, right? So this MV mode variable is only true if the model path, which defaults to 3D-2 mini, right? If the model path contains MV. So what I think we need to do is we need to modify this download model script, right, to download the MV, the multi-view models as well, and then it set the model part to the multi-view models, and then it should pick that up and enable multi-view as well. Let me try that, and yeah, let me see how that works out. Just let me do this as MV. Okay. All right. Okay. Yeah. So good thing is that seems to have worked. Now the MV model, the multi-view model, is being downloaded. I mean, to be very honest, I think we could have done it directly by just running this Hugging Face Up command and giving it the folder. But just to test this out right locally, I want to try the normal model one. Let's see. Yeah, it should take some time actually. Let's wait for this to complete and then we can see. Okay, so yeah, the models are downloaded. You can see this here. If you see, this 2 MB model is downloaded. Now I verified this, and if you remember last time we did change the script, so I changed it further. If you see the actual command, that has changed. You need to supply these parameters. Basically the model path should have an MV in it. That is how the code checks whether it should run the multi-view UI version or not, and then you need to give it a subfolder, the text and model path and everything. So if you're confused on what these parameters look like, I would suggest you look in the Hunyuan 3D 2.0 repo. Yeah, so if you check in the repo, you can find out the commands to run this multi-view model. So if I were to look at it, let me check. Yeah, so if you see, this is how this is what the grad.io commands are. So if you check for for multi-view, which is this one, this is the command. I just copied this command and replaced that in the script. I also removed the low VRAM mode since I have a GPU which has plenty of VRAM to run around. So I removed this, and that should actually work. So this is how it looks. Let us run this. So I'll just open my Anaconda PowerShell prompt. I'll activate the Hunyuan conda environment. Okay. Sorry, Hunyuan. I'll just get the name wrong. Yeah. Then I'll go to the folder. I'll go to Hunyuan. And yeah, I'll just run this run multi-view bat command. And it should actually start the UI for this. It'll take some time to load this model. Once it loads everything and it starts the UI, we can actually check the output here. Okay, you can see the app is running on localhost 8080 now. Let's try to start this. Okay, you can see the UI has loaded up. Let's add these images. Let's add the front view, the back view, the left view. I'm not sure what the left view is, but okay. Yeah, the left view, the right view. Let's generate a shape. It will take some time because this is the first run. Yeah, so the output is here. If you see, the output is much better than what we got from at least it's a subjective opinion. I mean, it cannot always be true, but looks better, right? Let's try to generate textured shape, which will actually map all these textures on this car. But looks nice, looks good for me. Plenty of details. I think one thing we can do better is all these, like, so since this is a car which was shot in, like, this photos were taken in studio light, right? There are a lot of reflections which are very difficult to model in cars. So if we were to get a photo of this car, right, without all these reflections, we would have got a better one, but we can only, like, it's good enough for an approximation. We are anyways going to 3D print it. It's not like we need a very accurate model and everything. So yeah, the model is being processed, the textured model is being processed. Let's see what's happening. Okay, yeah, so now you can see the model has been generated with texture, which is, see, these like these parts, right, these are because of the flash lights which come up. Yeah, if we were to get a better image, we might have got somewhat better textured model, but in our case we are 3D printing it, so texture doesn't matter for us. This is the model which we are going to work with. Wait, why is this so white? Yeah, so this result you can see because of face reduction, if I'm not wrong. Let me try to do this thing. Yeah, I think only Gen shape works better, at least in the side view mirrors, is what I've seen. So once we decide to export this, what I've found out is something somewhere around 2 lakh triangles in a mesh is a good enough point for 3D printing. Anything more than that is generally not very useful. At least the slicer I use gives an error if you have more than 2 lakh faces. So yeah, I've let's see what happens. Once this model is present, we'll export somewhere around, like the target face number would be somewhere around 2 lakhs. Will that transform and download it? Yeah. Looks nice enough. File type I'll choose as OBJ. Let's not. Yeah. So this is how the model will look after that many faces. I'll download this. Let's open the slicer, which is Orca slicer for me. Let me just drag and drop this model here. Okay. Alright, this is how the model looks. Let me change the filament color to white so that we can look at it better. Let me auto orient this. Let us import the previous model as well. I think this was the model, the Franks one. So this model was generated with the help of Trellis. Yeah, let me scale this a bit. I'll do maybe 250% since it's uniform scaled. Okay. Okay, so this is the model which was generated by Trellis, and which is actually not bad compared to. Let me change this filament to white as well so that we can do a true apples to apples comparison. Yeah. So this is Trellis. This is Hunyuan. I feel, I don't know, I might be completely wrong here, but somehow the mesh feels better in Hunyuan. It might just be that the export quality here was very bad, because I think that's the case here. But for this purpose, I think we can export Hunyuan and let's see how it goes. So, or should I print both of these? Let's print both of these. So I'll just scale them roughly to the same size. Okay, let me auto orient this. Let me auto orient this as well. Let's slice. Also, let me mark these. This is Trellis, so okay, yeah. So now we know which model is which, right? We have added supports. Okay, one more thing we need to do is just to preserve some level of detail. Let's do adaptive height, make it smooth. Same here, make it adaptive, make it smooth. Let's print this and see how it works out. supports have been attached. Let me try to remove those. Yeah, and we can see the final model of the car. So what I am trying to do is I'm trying to remove these. Yeah. Well, yeah, one of the wheels came off and the other. So if you see, yeah, the wheel that was supposed to be here just came out. That can be fixed, so let's not worry about it. I want to see how close the car looks to the car I have. Well, the supports are very, yeah, maybe let me try to cut them off from here. Okay, yeah, so this is how it should look, the wheel arch and everything. Yeah, it has mirrors as well. I think one thing that happened is I printed the model too small, so we are not able to see the details. Ideally, this should be a very simple print. This is a very simple model, but since I reduced the size by quite a bit, it'll cause issues. So yeah, let me try to fix these. Ideally, this is how the car looks. Like if we, yeah, I think this was a bad idea. Well, I have a setting which actually prints with better supports. So yeah, I think next time I might try something with better support profile so that it prints better. But the car is pretty close to what we want. Is it like, I don't think we would be able to do a comparison. Yeah, I don't think we would be able to do a comparison with this rough of it. So what happened was I took this printout after quite some time, and that actually causes issues. So what happens is these supports, right, then actually once they harden they become very difficult to remove. The best time to remove is like just after the print is done. Just get a plier and remove all these prints, and they will help you remove these. So yeah, I think let me clear this up. This is the other print, which looks much better, I would have to say. Yeah, let's see how this look turns out. Same procedure. I think the supports are a bit better to remove here because, yeah, so if you see, yeah, the supports are much easier to remove from here. Definitely this can be improved. This can be improved by printing intelligent supports. So yeah, yeah, one of the mirrors came off while removing support from this side, but the supports are much easier to remove here. I'm wondering what changed here. I think the model is slightly better in the sense that there are no open holes, or yeah, this is coming off much easier. So let's remove these. This wheel, yeah, the wheel arches, like the wheels were not very nicely attached to the body, and that is the reason these wheels do come off. Let me try to remove the front part and see how it looks. So overall I would say this print was much better. Which is difficult to find out. I Yeah, if you see, right, it has this Suzuki logo as well, like bits of it. The printer can only print as accurately as the layer lines allow. So yeah, it's not very detailed because that was by design. Like when we started a print, we prioritized speed over quality. If we want to print this better, we can actually try to print with a very small layer line, like which very small layer height, and that will help us print this better. Yeah, so this is how it looks. uh, Not bad. Yeah, so if I were to compare this is very close to the Franck's car. uh, yeah, so if you see, this is very close to Franck's. I'm not sure whether we can capture this in the camera, but because it is white, it's much harder to show these details. So it is quite detailed. So I tried to identify which model was which by printing something, but I severely misjudged the size with which I was printing. Anyways, after doing a quick comparison, I decided to print a larger version of the Hunyuan 3D model. Let's get this model into Orca Slicer. For the final print, I'm thinking of using the red filament. And let's also scale this up to 300%. Perfect. That is a much better size. Here's a quick look at how it'll slice and build up those layers. Looks good. Let's send it to the printer. Alright, the print is underway. Always fascinating watching the model take shape layer by layer. This print took approximately 2 hours to complete. And just like that, 2 hours later, we have a finished print. Now for the careful part, cleaning off all these supports. Let's break down the final result. Not a lot of image to 3D models support multi-view. Hunyuan handles it natively. Trellis on the other hand samples through multiple images while denoising. Hunyuan 3D with its clean mesh and native multi-view was the clear winner for me. Hope this helps. Like, subscribe, and let me know what you think in the comments down below.